नमस्कार दोस्तों. I hope you are fine, doing well in your life. Uh, Today my video comes after so many days. I have some personal work due to Holi. Actually, I have to go to my home and can't record the videos. But yeah, I have solved the problem of the days regularly. So today is 18th March and we are gonna solve the today's LeetCode problem of the day. And the problem is longest nice subarray. So in this problem we are given a array nums consisting positive integers. Okay, so this is the positive integers. Okay, sorry, before starting this explanation, I have to tell you something, that this video is a part of LeetCode problem of the day series, in which we are gonna solve the LeetCode problem of the day daily, and I will upload the explanation video on my YouTube channel. The video, all the videos present in the playlist given in the description box. Along with this LeetCode 75, we have also started the playlist for solving LeetCode 75. So LeetCode 75 are the most important 75 questions for the interviews. The link is given in the playlist. The link of the playlist is given in the description box. Okay. One more thing. Along with these explanation videos, I have created a WhatsApp group for the coders where we can discuss multiple things, any doubt, about any algorithm discussions, and we can connect to the various coders along the world. So we can create a community using that WhatsApp group. So if you want to join the community, you can just click on the link given in the description box. That's completely free. Okay, so we will gonna solve this video in a 3 steps, right? So first we will discuss the details, then we will try to solve the problem in native approach, then we will gonna solve the problem in optimized way. Okay, so I have written the codes here so that we can compile this video in a short time while explaining everything in a depth. So this question is longest nice subarray, and we are given array nums consisting of positive integers. We call a subarray of nums nice. So we have to take a subarray if bitwise end of every pair of element that are in different positions in the subarray is equals to 0. Okay, so let's say this is a subarray. So we have to check if this 1 and 8 make a 1 and 8 equals to 0 or not. So it is a 0. So yeah, but we have to check with 1 and 3 also. So 1 and 3 makes 1, right? So this subarray is not a nice subarray. So we have to find a nice subarray. We have to find the longest nice subarray. Okay, so let me explain it to you. So let's say we have given this nums, right, which is 1, 3, 8, 48 and 10, and let's say we have to check that is this, okay, let's say we have to check is this 1, 3, 8 is a nice subarray or not. So what we have to do is we have to find the end between all the elements in the subarray, right? So and the end of all the elements should be equals to 0. So then this subarray will become nice subarray, and we have to find the longest nice subarray. So in this particular subarray, end between 1 and 3 is not 0, because 1 and 3 is equals to 1. So this subarray is not a nice subarray, but we can see that this subarray 3, 8 and 48, so this is a nice subarray because end between 3 and 8 equals to 0. 3 and 48 equals to 0, and 8 and 48. So this 8 and 48 is equals to 0. So this subarray is a nice subarray, and this is the longest nice subarray present in this given array. So we have the answer 3 here. Okay, so this is the question, and how can we solve this problem? So in the native approaches, native approach is we can take all the subarrays, right? So let's say we have taken this subarray, then this subarray, then this subarray, and we have to find the and between all the elements between the subarray, and then we have to check if and between all the element in the subarray is equals to 0 or not, and then we will return the length of the longest nice subarray. So this is the native approach. So let's discuss the time complexity. First of all, for creating all subarrays, right, it will take n square time complexity, right, into for checking element between all the elements of this subarray. So it will take 2 to the power n, because let's say we have these subarrays, not 2 to the power n but n factorial. Okay, so n factorial. Yeah, so or I can say nc2. What is nc2? Not n factorial exactly, but it is nc2. So for picking up any two elements from the whole subarray will take the time complexity of nc2, and nc2 is nothing but n square, approximately n square time complexity. The total time complexity will become n to the power 4, which is huge. I mean, we cannot solve this problem in n to the power 4 time complexity, but yeah, it's like easy to it's necessary to discuss the native approach. So now how can we optimize this? So whenever we are talking about any subarray, we are going to solve any subarray problem, we have to think of a sliding window approach, right? So we have, in a sliding window, we have to first think of the expandation of the window, then we have to discuss about the contraction of the window. So these two operations can create this problem. We can solve this problem in O and time complexity, right, using the sliding window. So how are we solving this problem using the sliding window? There are two approaches. So first is we can see that if we want that all the element of the array having and operation equals to 0, we need a unique bit. So in a window, if we take bit of all the elements, right, so the overall bit in this window should have only unique places, right? What I mean is, let's say we have 1, we have 2, and we have 4. So the bits are 4 will have 1 0 0, 2 will have 0 1 0, and 1 will have 0 0 1. So all these have a bit at the unique places. So we have to check that if all the elements have the bit at unique place, then we can say this subarray is a nice subarray, right? Okay, so what we can do, so in this solution, what I've done is I've created two functions for expanding the window and for contracting the window. So while expanding, I've created a vector of int frequency. Frequency means it stores the frequency of bit at ith place, and I've created the frequency vector of length 32 because integer have 32 bits only. So bit p is bit position, so it currently is 0. Flag true means bits are currently only 1, matlab there are only unique bits. Okay, now I am creating this while loop while my bit position is less than 32, and x is nothing but the number which I want to check, right? with this frequency array, that if x can fit in the current subarray or not. So if x and 1 means x has the bit at the 0th place, I will increase the bit position, right? And if the bit position, if the frequency at that bit position is greater than 1, that means x cannot fit, because the bit position, the frequency at that bit will greater than 1 means there are 2 bits, right? So we have to contract. So I will return false here, and then I will left shift x. That means now we have to check at the next bit position, and then I will return the flag. In contracting, so basically what I am doing is I am creating a vector frequency array. Now these are some variables in which I will store maximum length of the nice subarray. This is the starting of the sliding window, this is the ending of the sliding window, and n is the size. So while n is smaller than size of this given array, I will check that if I can expand the window or not. So if I can expand the window, I will check the maximum length, and if my flag is false, that means I cannot expand the window, I will contract that, right? And in contraction, what I'm doing is in a similar manner, I'm just decreasing the frequency and checking if the frequency is still greater than 1 or not, right? If that is greater than 1, then again I'm returning false, and again contracting the window from the starting point. So this is how I am solving this problem and returning the maximum length, right? So this is one approach. So the time complexity of this is I am traveling. So I am using a while loop. So the time complexity will become on and this 32. So on into 32. So overall time complexity will become on, because 32 is constant, right? But can we optimize this? So yeah, we can optimize this. There is a approach. So we can optimize this using this approach, right? So in this function, what we are doing is we are creating a mask, right? The used mask. We are creating a mask named used, and used is nothing but a mask which store the position of bits of that window, right? So used is nothing but all the used bit inside the sliding inside the window, and if the current num_i, that means if the current element has the bit present at the used position, right? So that means that is not a unique bit. So I will contract this window, right? So I am using I for the expansion and j for the contraction, and this ZOR is using for the contraction, right? So I will contract that window from the starting point and remove all those bits which are present in the j, okay? And then I will again expand the window and using OR operation, and I am using OR operation for the expansion and ZOR operation for the contraction, okay? And then I will store the result in the maximum. So in this operation I am just using a single loop. Single loop means just on time complexity, not 32. So this is 32 times faster, okay? So yeah guys, that's all in this video. If you are confused in this OR operation, ZOR operation, I suggest you to go through my previous videos in which I have explained these operations in the detail. And even if you want me to explain these operations in a depth, you can ask me in the comment section. I can make a video separately for these operations, right? Okay. And also you can ask me directly in the WhatsApp group, and we can discuss these approaches there only, okay? So yeah guys, that's all from my side. Thank you for watching this video. I hope you have a nice day. Thank you.